In lesson 7.2, we'll be talking about transformations. And in this investigation, we're going to look at translations, reflections, and rotations that we talked about in the previous lesson. And we're going to use this particular figure here, which I call a flag, as the basis of the study. So what I want you to recall for future slides is that this flag is what I'm going to call the original figure. And I'm going to do things to this flag and talk about it in the context of what's happening to this flag. You'll notice that this flag has 5 distinct points that I'll be talking about. The point A at coordinates 2, 1, the point B at coordinates 2, 4, the point C at coordinates 2, 6, the point D at coordinate 5, 6, and the point E at coordinate 5, 4. So one of the things that we can do with this original flag, again, here is my original flag, is we can rotate it either 90 degrees clockwise or 270 counterclockwise. They actually do the same thing. So in this particular example, if I look at the rotation, this flag is being rotated 90 degrees in the clockwise direction, or I could also say that it's being rotated 270 degrees in the counterclockwise direction. Now the rule that occurs when this is going on is that your coordinates called x and y turn into y, comma, negative x. Let me show you what I mean by that. If I look at the point, for example, D, and highlighted in pink, and we know that that D point that's highlighted in pink was called 5, 6. Then when this red flag is transformed, the new flag has the new coordinates of 6, negative 5. And you will see those coordinates for D down below. And that's the rule that applies every single time that you rotate something either 90 degrees clockwise or 270 counterclockwise. It is the same exact location, and you can describe it either way. So if you see 90 degrees clockwise or you see 270 counterclockwise, they mean exactly the same thing. I also could rotate something 270 degrees clockwise or 90 degrees counterclockwise. Again, remembering that this is my original flag, I could go 270 degrees in the clockwise direction, that's this one, or I could go 90 degrees counterclockwise, that's this one, and they still have the same rule. This rule that they have is that your coordinates go from xy to opposite of y, x. Let's use the D again. So when I look at the D, highlighted this time in orange, and I see that that D coordinates were 5, 6, that would be considered my x and my y values. When I write them after my figure has been transformed to the new figure, I take the opposite of y, so the y was a 6, I take the opposite, put it first, that's negative 6, and then I write down the x, which was a positive 5. And if I look on the new image, instead of the original red one, what I notice is that the D is negative 5, 6, and actually that is incorrect. So that actually should have been negative 6, 5, and an error. So these coordinates should be negative 6, 5. Glad I noticed that. On our next slide, we're going to talk about our last rotation. This rotation is 180 degrees. And it doesn't matter whether you talk about it in the clockwise direction or you talk about it in the counterclockwise direction. Clockwise is 180 and counterclockwise is also 180. So either way, you're doing a 180 degree rotation. Now the crazy thing, and I didn't mention this in the first couple slides, is that the point of rotation is the origin. So everything is being rotated, spun about that point. That's not really going to influence what happens in your homework or your quizzes or anything like that, but just so you know. Our rule in this case is if we look at any particular point, let's say for example we continue to look at the D, which was 5, 6 in this case, that location of 5, 6, which were my original coordinates, or in other words my x and my y, change. And I take the opposite of the x value and the opposite of the y value. So now I'm at -5, -6 for my new D. So if I look at my new D, what I notice is this coordinate is incorrect again. I typed it in wrong on my original. So this is supposed to say, instead of what it said there, -5, -6. And that D, in that particular case, should have been actually the edge of the flag right here, just so you know. So these got kind of distorted when I printed this image. So -5, -6. Next, we're going to talk about how you make a translation. A translation, if you remember, is a slide. So the last three figures were doing rotations. Now we're going to start in on translations. And these translations mean you're sliding something. So look at my original flag here, again. And what I notice is that this original flag has moved to the right a certain number of units. And if you look at the two x values, let's say we're looking at a this time, if I look at my a value, what I notice is the new a value went from the x being a 2 to the x being an 8. Or in other words, I moved to the right 6 units. And what you'll notice is that your original coordinates of 2, 1 turned into the units of 8, 1. Or in other words, what you see is the rule. I took the x value and added on 6 units, but I left the y value. In fact, you can look at any of the x values and you'll see that this happened in every case. Look at D, and you see that the 5 turned into 11. Look at the E, again the 5 turned into 11. You can look at the B, and the 2 turned into an 8. But all the y values stayed the same. So this is called a horizontal translation, or a translation in the x direction. And what you'll notice is the only thing that was affected was the x value. So your x and y go to x plus 6 comma y, which indicates that all x values have 6 added to them. Here's another translation. This translation, instead of moving to the right a certain number of units, you can see has moved to the left a certain number of units. And so as I look at my original flag in red, and what has now happened to the original flag, I've gone left 4 units. And what you see is the rule that indicates that is I take my x value and subtract off 4. So I can pick any x value and do that. So for example, if I look at the E value in the red flag, it was a 5, and the new E value is a 1. Why is that? Because 5 minus 4 is 1. I can look at the C value, which is a 2, and my new C value is a -2, because 2 minus 4 is -2. And so what ends up happening is these rules indicate what's happening with each value. You'll notice that in this particular example that my x value now becomes x minus 4, but my y value remained the same. So what you see here, highlighted in the light blue, is the rule that describes what's happening in your translation. So we've moved to the right and we moved to the left. I could also